All right, here we go. So we're going to start off. Let's see. Does anybody pay their own phone bill in here? Yeah, phone bills. Okay. Who don't I call? David, you pay phone bill? Okay. What kind of phone service do you have? So just gonna put it as one. Let's just read. What carrier do you have? Boost. Okay, Boost. Boost. Okay. And with Boost, you just pay a flat rate? Yeah. Okay, cool. So what is the flat per month? Flat rate? 90. 90 bucks. Okay. Anybody pay more than 90? No? The first period I had somebody, they said $200. I was like, I don't even know. Maybe they have 3 phones or 2 phones, one for each ear. They like stereo. They're like, I can't listen to things in mono, so I have 2 phones. It's great. One for each day.
Oh my God.
So I don't know what plan she had. She had AT&T though. Maybe that's why it's so expensive. Okay. Yeah, I have Verizon. It's not over. It's not over that much.
45.
Yeah, I don't understand how 200 could be. But I mean, and yeah, most plans like that's probably unlimited, right? Unlimited everything, most of it. We gotta inform that student what's happening. Okay, so I made up this first period. Let's see if it works. Anyone roaming fees? You ever been somewhere you're like, man, roaming fees are super expensive? No. Okay. So I had a friend actually. She was part of a science expedition at McMurdo base in Antarctica. And Antarctica, I was thinking about it. I was like, I wonder what the roaming fee for Antarctica is. So I'm gonna say it's $10 a minute. This is where you're like, yeah, long distance relationship sounded good until it was $100 per conversation. Then I was like, we need to break up. So Boost Mobile in Antarctica isn't the greatest option. Okay, one second. Ava, let's see. Okay, good, Ava. Yeah, okay, Ava's back. She had to use her hotspot. Yeah, so look, so $10 a minute for roaming fee from McMurdo Science Station, Antarctica. All right. Now, we have to create a linear function for this, okay? Linear function. And this is going to be y is equal to mx plus b. And really what we're going to just be inputting these 2 values because they're parts of this equation. We're going to input it in for the m or the b. And my first question to you after you get that down is which of those values is a constant value? That isn't going to change. And you could just think about it in the scope up here of what we were talking about. But which one of these is like, for sure you're paying that every month, you're paying this amount for sure, right? The flat fee, right? Every month you pay the flat fee. If you don't, your phone doesn't work. So now I want you, that's probably too big of a hint, but I want you to create a linear equation with this information. And then I want you to tell me how much it costs to talk to someone from Antarctica for 20 minutes. Yeah. 20. See, that's how that student first period, they're roaming all over the place, getting all the extra fees. Jeez. I know. They're like, we need to talk really fast. Okay, speed it up.
I know.
That's it. Hello. Oh, great. Oh, that's good. What else? No awkward conversation. It's like if it's like silence, awkward silence, you're like, we gotta go.
You gotta plan that out.
You give them like 3 seconds before you're like,
You gotta plan it out.
you gotta plan it out.
What
Bullet points.
conversation you're gonna hit first.
I'm gonna email the conversation to you.
This
In
is
fact,
how it's gonna go. You gotta respond.
It's a
Like
script. It's a script.
this.
Yeah. How are you? I'm fine. How are you? Okay, tell the person around you what you got for your linear equation. Tell the person around you, anyone around you. If you didn't know, ask them if they know. What did you get for your linear? You can throw it in the chat too at home. All right, we got something similar. You see something similar to people around you? All right, get a chance to check. All right, get a chance to check if you haven't yet. So what I was saying here, and maybe these are like notes that'll just be helpful. Okay, so if you're understanding everything I'm saying, just for those at home, if you're understanding everything I'm talking about, it's not enough. I want you to have hints so you don't have the stress of remembering everything. Okay. So B is a constant value. This is always going to be the constant value because there's no X to like we're doubling it, we're not tripling it. What is this value? 90 every single month. This is a rate. This is a rate. It's saying the cost per minute. $10 per minute. So if you speak for 2 minutes, it's $20. 3 minutes, it's $30, so on. So that's how I organize and think about these functions. I think about, well, this one's the one that's variable. This one's the constant value. So what are we going to go with? Y is equal to 10 x plus 90. So, you get 10 minutes talking on the phone, and that costs $100 if you're calling from Antarctica. Okay. So how much was it to have with our long-distance relationship here to talk for 20 minutes? Yo, too much. All we have to do is plug in 20, you see? Because it applies to the value that is about the roaming fee. Because we've set it up that way. There's no other way to set it up. If you put it the other way around, you're like, whoa, $90 a minute. Doesn't make sense. So always start with this. Always start with this. Always start with the constant. Trying to figure out what is the constant value, and that's always going to be this B value because there's no way for that value to change. It's always what you put. So what do we get here? 200 plus 90? God, $290.
No. No.
Yeah. No?
I'm not doing that.
You're not doing it.
Hey, rich.
Well,
I know.
that they're living in Antarctica. They don't have anything to do. They're just saving their money. Maybe they actually.
That's a lot of money.
I know.
It's true.
At that point, I'm not paying.
That's what you're talking for 20 minutes a month.
Yeah, right. So you're like 1 minute,
1 minute every day.
every other day. That's 15. But yeah,
1 minute every day.
a minute a day. 1 minute a day. They can't even talk. You're just saying things to them. Hello, how are you? I don't care. This is what's happened today. I saw a lot of snow. Really cold. Yeah, you're like, we'll have a text interaction only. All right, $290. But this is actually something that, when you're planning out, you're looking at different plans. There's a lot of mental math that will help you not get tricked. Often I think about these things as I don't want somebody talking me into a plan that makes sense, for the first 12 months. Then what happens after the introductory cost? You're like, oh, it's no longer this cheaper amount. You have to pay more. So just keep in mind, being able to think analytically like this is going to keep you from being tricked. I mean, honestly, marketing is to get you to buy stuff, and that's not always in your interest. But buy what you want. Uh-oh. See? How many people are like, oh, it's the first of the month. I gotta pay it. All right, here we go. Number 2. We're just going to work through this, talk about it, make stories up about it. And this one is, okay, let's do this. Anybody grow up around like lowriders or anything like that?
Yes.
Yeah?
Yes.
Okay, what are the wheels? It starts with a D. I have a shirt, actually, that has this wheel on the front. It starts with a D. It's got cool spokes. What's the name of the wheel? This classic lowrider wheel. This is two like 90s, 80s kind of like things for you. D-A, day. Maybe you don't know. It's fine. Dayton's. You ever heard that? Dayton's. Yeah, it's like something you might have heard in like. Oh, is that right? Yeah, ask them if they know what a Dayton is. Tell them your math teacher has a shirt. It just has a Dayton on the front. Oh, man. That's my favorite shirt. So, look. Actually, Daytons are a little bit more old school. They have like a center, and they have these spokes.
Yeah.
And then also the wheel has these little like, it has like the little tri kind of, there's a 4 in the front. This goes around. That's a really bad Dayton. Let me pull it up. I'll do it later. So this wheel is way too, it has to be low profile. That's not cool. What is this car? I don't know. It's horrible. Put Daytons on like a VW Bug. Okay. So we got our Daytons here, and I'm going to redraw the Dayton because let's just draw a circle. Let's put a diameter down through the middle. That's A. Let's throw another spoke in there. And let's put these points that are on the circle. Let's call it BCD. So this wheel, the person tried to go like off-roading with it. They put Dayton's on a Jeep and they're like, I'm gonna go drive to Eagle Lake. Okay. So they end up driving back and they only have 3 spokes on their wheel. Somehow the wheel stayed on. So here's this wheel, brings it to the shop, and the guy's like, why did you bring your lowrider to off-road? It's a dumb idea. We have to like notice everything that they have with this wheel. Let's notice anything that is the same, anything that is bigger or smaller. Foxy likes that. So what do you know about spokes? What is one thing you know about spokes? Not deep kind of like knowledge. What happens if your spokes aren't the same size? Yeah, it's gonna be awkward. It won't be a circle, right? Think about it. The spoke starts in the middle. If one is like longer, maybe it gets busted. Then your wheel isn't gonna be circular, and you're not gonna like your wheel's gonna fall off. It's not gonna work. So what do we know about AB, AC, and AD? Tell the person next to you. What do you know about AB? This guy, AC, and AD. What do you know about all of them? What do you know about all? Okay. I hear good words over here. I heard all the same. Okay. The word we use, put little tick marks showing that those are the same. Tick marks just show that those measurements are the same. And then what we're going to do is we're going to say AB line segment is congruent. The same, the word for the same is congruent. And then we'll say it's the same to AC. And what's the last one I need to put there? What's the last one? AD. Easy. It's easy like that on the test too. They just have you. They have a few examples of like things they're observing, and they're making relationships. You have to pick the one that makes sense or doesn't make sense. So now I'm going to ask you, looking at this arc here. First, how do I write? Got a yellow and a pink arc here. The parts of the wheel. How am I going to say and label this arc? I know it's going to have BC, but what do I need to do to show that it's BC, the fluorescent arc here? What's wrong with the symbology here? It needs something else. Yeah? A little rainbow on the top? Yeah? A little arc on the top? Remember, that's how we show arcs. And I want you to relate arc BC to arc CD. How do those two relate? Tell someone around you. How do they relate? And it could be something real easy like, well, this one's, that one's, like something real basic. How do they relate? Beyond the labels, they do have the point C in common. How about if you were putting like chrome finish around the wheel? The chrome fell off because they were trying to off-road. What would you say about this chrome right here versus this chrome? Like how much do you have to go? You have to go to the shop to grab some chrome. What do you have to grab? BC versus CD. What's something you could say about those two? I'm being too abstract. Little thing. Yeah. Ooh, I like this. I like this observation. And that's not what I was going for, but you're right. You could say that it's a semicircle if you combine them. It's half semicircle. But what I was going for, and I think you'll see what I was trying to do here. I hope CD is greater than BC. That's it.
Yeah.
That's it.
That's it.
And maybe that was like an idea you already thought, but you're like, well, that can't be what you asked. But CD takes a little bit more of the chrome plating. You better order a little bit more if you're doing something special. If you have special paint you're putting on there, maybe you're pinstriping around it, something like that. My uncle is like the king of pinstriping. He used to do a lot of lowrider cars in LA. That's hard to make perfect lines and like the little squiggles at the end. I love that style. Okay, so you see how we're relating that. What else can we say? How about this one? Angle BAC and angle CAD. Go ahead and relate those two. And it could be something as simple as what we just did. You're going to LA, Eva? Oh, yeah? Okay, cool. Where'd you go in LA? Moreno Valley?
Yeah.
Oh, I know Moreno Valley. It's like more inland.
Yeah.
Wait, where's that? It's like around Corona? Yeah. What's up? Boom. That's it. So we just had good input. We had noticing that CAD is greater than BAC. That's it. This type of problem is just, I could have just said, well, here's a circle. Tell me everything you know about it. These are the kind of answers when I say, to tell me everything you know about it. That all these things are the same, that this arc length is greater than this one, that this angle is less or greater than that one. And just remember, it opens towards the greater one. That's the main thing with it. Okay, we got our wheels out. We got our wheels. We're going to put some spokes here. All right, while you guys finish that up, I have to pull up a picture of a Dayton wheel for those that don't know and need education and what's really important in math class. Oh, no. Dayton wheel. They only had to fix one wheel somehow. All right, let me show you. Oh, there it is. That's a pretty good one. That's a good one.
Oh.
Yeah.
You guys know Dayton's, right?
Yep.
That's actually exactly like my shirt. If you see somebody walking around with a shirt like that and a hat, you don't recognize me because my mask is on and my glasses. It's me. Nobody has that shirt. All right, how many people at home have seen and know what a Dayton wheel is now? You guys seen this before? You guys know it too? There's not many cars. There's not too many in Northern Cal that go this LA style. But I like both styles. This is more just like classic. Real old school. Real old school. Yeah, I grew up off Whittier Boulevard, so that's all that is very, very Humps for the Boulevard. You know that song? It might just be an LA style song.
Yeah.
There's local stuff that aren't really shared as much all across the state. But I like that part too. NorCal has its own style that's kind of interesting. I like it. All right, folks, here's number 3. All right, I'm going to see if you guys like this story. So I was at the FC Republic. I told you I went to the taco truck or the Tate's nacho truck. And I thought up an idea. Here's the taco truck idea I came up with. You don't have to draw this if you don't want. You can if you. What if you had a taco truck that made this is the name of it. Tri-pan French fry. Tri-pan French fry. What do you guys make? What kind of food do you make at a food truck that's called Tri-pan French fry? Almost.
I don't know, the first ribs and fries.
We're talking triangle pancakes and French fries. First, how do you make triangle pancakes without making them? That seems like hard to cook. Yeah, you need a mold. Let's make a new one. This was first period. Give me 2 foods to mix. All right, give me food.
Tacos.
Tacos. Give me food. Yes. Oh my. Yeah. Okay, then that's definitely what we're doing. All right. This was first period, and that was funny for first period, but doing a joke twice is not fun. So this is our taco spaghetti truck. We'll call it.
What is the name?
Oh man. Spataco. Taco. Spataco. Okay, and then it's like a taco with spaghetti
Oh
in
my
it.
god. It kind of reminds me of space.
What? Spataco.
Space potato.
Space Spataco. Because there's an element of, asteroids and aliens. There's an alien over here. Okay. Somehow you put what in your space rocks, like pop rocks. Pop rocks in a spaghetti taco.
Yeah, the meatballs.
Ah. Yes.
That is like.
What is that called again? Oh wow. So they've already done this. I know, diabetes in a package, cold package. All right, so we have space spatacos going on. Oh yeah, there were a lot of them, were there, huh, Puffy? Okay, the main thing here is I'm gonna have to make this new. Okay, go ahead and make a figure. Go ahead and write figure, and let's put 1. Let's put 2, 3, just like that. 1, 2, 3. All right, and then what we're gonna do is we're gonna make, for 1, there's just a taco, so just make like half circle, real basic taco. And then we're gonna do it where, let's see, we have a taco plus 2 pieces of spaghetti. Oh, it's starting to look like it. Now it's a spider. Spataco. Spataco spider. Jeez, say that 10 times. Space Spataco spiders. No. Space Spataco spiders. Awesome. All right. So we got 2. And then let's go here for the third one. For the third one, though, we have 4. Now it's more of a spader. Spader. See, all my words are messed up. Anything that starts with an S, I'm just done. All right. Now, I want you to figure out what the 10th figure will be. First figure had 0 spaghettis. Second figure had 2. Third figure had 4. Figure out for me how to get to the 10th. And it's just deductive. Yeah, you can count it, mental math. You can make a table. You can write things out. So actually, mental math's the hardest. Find a way to figure out how to show me with writing how this is going to go. It sounds like spy taco. Okay. Now we got space, spataco, spiders, spy. No. Space.
Spy spiders.
Jeez. Space, spataco, spy spiders. SSS. Side. All right, so I want you to come up with a strategy. How are you going to get out to 10? Are you going to count it? You know, I gave a hint. You could make a table which has the figures and it has the amount of spaghetti. Okay, but how are you going to figure out on your own how to get to the 10th figure? The 10th figure. Okay, how is it going to build every time? And I need you to do it more than just mental math. Let's find a way to actually have something repeatable that we can do here. All right. Space Spataco. Space Spataco. And the guy that sells it dresses up like Mario or Luigi, but like an alien version.
Yep.
Yeah. Now it's getting expensive because you got costumes for your employees.
How much are we charging for these?
Yeah. $15 for just the taco. Yeah, it's like yeah. Yes, it is. Anywhere the truck goes. $15 for just one taco. You get 2 little threads of spaghetti in there, and it's $35. This sounds like Cal Expo, like Cal State Fair costs.
Yeah.
And then you get over here to 4 pieces of spaghetti and a taco, and you get it's like $60.
Jesus.
Your Coke, the drink alone is like $12. I've seen that $12
Yeah.
Coke.
We should make them like street taco size.
Yes. Yeah, that's right.
If you buy 2 or more tacos, you get a $10 discount.
There you go.
So you're like, it's only $120 for 2 tacos, and I give you $10 back. You only have to sell to like 3 people per day. You make your overhead.
I'm sure people are crazy enough to buy that.
Well,
Oh my god.
you know, there are crazy people who pay a lot of money.
For
There are people.
people like for
That's
stuff
true.
Like this.
That's true. It's like all super like specialty, kind of gentrified, kind of like all that realm of people have money. All right, excellent. So I think that one of the best ways, well, tell your neighbor now if you got to 10. I'll give you another moment, and then tell your neighbor, check with them, but I'm going to start setting up how I'm going to do it. Tell your neighbor, if you got to guess, you got to guess. It counts. What do you got?
A lot of spaghetti.
Yeah,
It's gonna be a lot of money.
breaking the bank.
They're breaking.
I know.
You're like, no cash because you don't carry that cash. You can't carry it. You're like, we only take Venmo, or you can trade Bitcoins. We'll take Bitcoins, Dogecoin, or Ethereum. No, I'm not going to go cryptocurrency on you.
Just give me the credit card information.
That's right. Security number. Oh, jeez. Okay, and one thing you can do is we can start by saying how many spaghettis we had to start. For figure 1, we had 0. Figure 2, we had 2. Figure 3, we had 4. So what's happening between, remember this where we had like a common difference? How much are we increasing by? By 2s, right? So look, it's plus 2, it's plus 2, it's plus 2. So guess what? We're counting by 2s now. 6, 8, 10, 12, 14, 16. Whoops. Did I do it right? 2, 2, 2, 2, 2, 2, 2. Yep. 18. Okay. Now, this is one where you could say, well, you're adding 2, or you could say you're doubling it, which is different, right? Now, one of them is linear, one is exponential. If we're just adding 2, it's like a linear thing, right? It's going up the same amount every time. But if we are doubling it every time, that's that other type of equation we were using, the different function. Instead of linear, what was that other function we called that? Starts with an E. Yeah, exponential. Exponential functions are growing like it doubles every time. Remember bunnies, like the exponential functions with like bunnies and growth and doubling, tripling. That is more exponential, but we're going to go with this being linear. So thanks, Kimberly. Perfect. We're going to go with 18 pieces of spaghetti for the 10th figure. Okay. Who got 18? 18? Okay, excellent. You see how that's more of a reasoning problem? Okay. We did a lot of work creating this space spataco.
I'm proud of you.
Proud of it. Is there just like spaghetti like falling out the back all the time?
Or this is like make spaghetti colored streamers so that they drive things.
They just pop out. There's somebody tailgating you behind you, and you're just like, you have a special like bucket here of spaghetti and it just falls on them. I love that.
I mean,
That's what they get.
Wait, this is like a whole experience.
It's
Kind of
just-
fun, like in a truck.
It's a whole system. What? I love it. All right, next. I think we might have time just for like maybe 1 or 2 more, but we're just going through them kind of leisurely here. All right, this one. This one is more mathy. 4. We are going to solve. Ooh, that's horrible bracket. We're going to solve this system, and I'll get out of the way once I do this. Okay, I'm going to solve this system, and we're going to solve it with substitution, because it helps us develop other skills too. We're going to solve it with substitution. Now, think back to this, because this is a system. Remember this bracket? Means that those are related. It's like 2 planets in a solar system. They interact with each other. The gravity pulls them around. It keeps them in check, right? Keeps them the same solar system. Same thing here. This Y can apply to this one. This X can apply to this one. It's like it's all in the same shared area. So we can relate them in special ways when we have this bracket that shows it's a system. So maybe you need to even write that just to remind you. You're going to see systems all over the place. It's a system of equations. Okay, system of equations. Now, systems have a few ways that we solve for them. Our answer is going to be an X and a Y answer. But substitution involves us substituting one variable in for the other. But we have to isolate the variable first. So I'm going to suggest this. I want you to take this equation, and I want you to convert it here so that you solve for Y. So what do you have to do to solve for Y for the top equation? And we're going to write that one right down here. What do you need to solve for Y, to isolate Y? Just one step. What do you think? Because I look here and there's Y, it's connected to this 2X by addition. So maybe we can break that chain. Subtract it. Nice. And Kimberly says this too. Perfect. Jaden, Kimberly. -2, X, both sides. You see? So, I mean, you could forget about the bottom equation. Right now, we're just thinking about the top equation here. You can deal with them separately, but as a system, they relate to each other. So if I am subtracting 2x from both sides, it's going to cancel on the left. I'm going to end up with y is equal to negative 2x plus 11. And you could have kept it as 11 minus 2x. I just tend to always put things, now it's a linear equation. It's in that form I'm used to. So it's always helpful to put in a form you're used to just in case you need it in that form later. So now look, you can cancel and cross out that top equation because we're not going to use it anymore. Now we have the two equations in the form we need in order to do substitution. Okay? Put parentheses around this second one too. That's going to help us visualize this. Okay. Now one thing I know about this is that this y, because it's a system, is the same as this y here. This y, since we solved it for it, now we're ready to take what y is equal to, which is all of this, and since we're doing substitution, we're going to put all of that into that y. You see? Because they relate in a certain way, if we solve for y, we can then substitute it into the other part. So watch, I'm going to rewrite this 6x minus 2y is equal to 18. I'm going to write it down here, 6x minus 2. But I'm going to leave space for what? The equation. And we call it actually, this right here is just a quantity because we're not going to put the whole equation, which y equal to that. So we're putting this quantity in there. But I know exactly what you mean. Let's go ahead and put it in there. It's going to be negative 2x plus 11. And actually, guys, from there on out, it's all, we have one variable, there's x left over. So do some of this, combine your terms, solve for x. Okay, this is minus. You can see all right? It's minus. Okay, so distribute, combine, solve, done. Boom. You got x. Okay, so don't forget about the other part because remember it's where they cross, which is a point. So let's see. Oh yeah. Great. And you can choose any. It doesn't matter. Choose any of the equations. Yeah. I always choose just the easiest one, even the one you converted. Yeah. Okay, I'll get to the next step. If you're not sure or you want to check your work with me, this is negative 2. Negative 2, remember. So we get plus 4x minus 22. So double check your work with that. Remember that you're distributing that negative 2. Okay. Nice. Okay. All right. This looks like we can probably combine these. Yes, we can. 10x minus 22 is equal to 18. Mm-hmm. Plus 22. 10x is equal to, whoops, 40. That's a weird 4. So what do we get for x? Yep. Yeah, we get 4. 4. And awesome, I'm done. Am I? No, not quite done. I tricked you. Sorry. Not done. Not done. What do I need to do? Last step. Yeah. Remember that anytime you have a system, and write this here, system, your answer is x and y. Your answer is x and y. So it's awesome. Yeah, we got 4. And now we have to find the other part of this point. Because essentially this system, these are 2 lines. I can't tell what they are right now, but these are 2 lines, and this answer is where they intersect. It's where they intersect. You're going to talk a lot about that in Math 2, 3, all that. Because this is how you figure out, okay, I want to start a t-shirt company. How many t-shirts do I buy and sell them for? You can do the math out for that and figure out this is the exact cost that's going to give me the most profit. Anyone that is running like a business that's super successful is using those ideas all the time, okay, to make informed choices. There's no guesses in business. unless you're probably struggling, honestly. What are we going to do with our x is equal to 4? I say we plug it in here. It's already set up. You can plug it in any of them, but that's already y is equal to. Y is equal to negative 2 times 4 plus 11. Y is equal to negative 8 plus 11. Y is equal to 3. Boom. Remember your answer. For systems is always x and y. And that's like a little note you can have. So you go through your notes. You go through your notes and you see the parts you got to, keep in mind for the test. Looking over these notes and maybe the homework assignment for 5 minutes before the test is going to help you a lot. Help me too, because if I get good scores, then my students get good scores, I get good scores. So yeah, do your best with it. Do your best with it. He is doing all right. He is doing good. All right. Thumbs up, sideways, down for systems. Yeah? Okay. Good. All right, let's keep going. I think this might be the last one, though, because we have like 3 minutes, and this one doesn't take too long. All right, here we go. Let's do this one. All right. Number 5. What? All right, thought you said something. You ever say something like what, and they said what, and you say what again? What? I think that just happened. Y is equal to 2x plus 1, given this function. And in fact, are you guys okay if I write it like this? F of x is equal to 2x plus 1. Is that going to trip us up when we see that? Who needs a reminder of that? Anybody? So when we have this is called function notation. Function notation. You don't need to multiply f times x. This is literally just a way for us to remember what we plugged in for x. This is function notation. It's not a big deal. If you're like, I don't remember that, it's not a big deal. You don't ever have to deal with what's on the left. But let's see. Now we need to remember this. Domain, and I want you to put some brackets out there, and range. I want you to put colon and then some brackets. Okay. And with this, first off, we got to remember what is domain and range. One is talking about x, one is talking about y. So tell your neighbor which one is x, which one is y. If you remember it, if you don't, tell your neighbor, I don't remember. Tell your neighbor, someone around you. Just get their attention, look for another person if they're not there. Yeah. You guys want a way to remember you never forget? No. Yeah? What do we know about, well, does anybody remember that? Because we'll have a way to remember right now, kind of. So it's not solid. It's not concrete yet. I want you to just make some kind of highlight, maybe go over D and go over R a little bit darker. Because what do you know about D compared to R? Just something real basic. It's like a mnemonic device. Like D in the alphabet comes first. D comes before R. Anytime you make a mnemonic device to help remember, keep it consistent. For instance, when I'm doing math, I never will tell you a mnemonic device where it's like, no, it's not alphabetical order. It's the opposite. If you keep it organized where you're like, I only use alphabetical order when it's alphabetical order instead of it's the opposite or something weird. So watch. Here's my mnemonic device. D comes before R, right? X comes before Y. You see? Never change those around though. If you're using alphabetics, don't make it where, well, D comes or R comes after R, so X comes before. Just keep it always. D comes before R, so X comes before Y. And if it doesn't work out that way, don't use that mnemonic device. Don't use that way of remembering. So this is where we're going to add 1, 2, 5. The domain has 1, 2, and 5. Good, Marco. Boom. Now, if I would have just said my domain is 1, and I said find the range, what would we do if I said the domain is 1, find the range for the domain being 1? What could we do to find the y value for that corresponding x value? What do you think? I didn't verbalize that as well, so I want. Yeah, Marco, thanks. Plugging it in. If I said the domain of the function is 1, find the range, you would take 1, you'd plug it into x, you'd find what the y value is for that one. So let's do that, and then I want you to do it for the rest. Because we're going to end up with 3 different values for our ranges, and they are going to be corresponded with the x value that we're plugging in. So watch. Oh,
Yeah.
what is that? A 1?
Oh, yeah.
That was like the most delayed reaction. It actually was from what happened in the beginning.
That happened last month.
Last time too.
I don't. We can only deal with the present. I can't keep track of all the classes. What's happening? All the classes in the past 4 classes. Then I have 20 classes memorized. All right, watch this. F of 1. I'm plugging in the 1. F of 1 is equal to 2 times 1 plus 1. Okay. So when I do this, that's just using function notation. It's not anything else I have to do. This is 2 plus 1. So I know that f of 1 is equal to 3. When I plug in 1 with function notation, it helps me remember what I plugged in. That's all function notation is. You don't have to solve anything more. If you get it into this final phase here, if you missed this day when I was talking about it, no worries. F of 1 means that I plugged in 1 for x, and I end up with a value, and this helps me remember what I plugged in. That's all function notation is for. So I'm going to put 3 here. So figure out the other 2, please. So essentially we're doing f of 2, and then we're doing f of 5, and we're going to find what those are. And we'll end with this. So just make sure you get those 2, and then double check with your neighbor. Help them out if they didn't quite get it. Say, hey, why did you get it? Nice, Kimberly. Nice. All right. But function notation, you have to get used to it. What I like to do is I'll take the function and I'll leave a space for where x is. Because then I just think, well, function notation reminds me of what I'm plugging in for x. Put 2 there. If I put 2 there, then I know that it's going to be 4 plus 1. I know it's going to be 5. 5. Whoops, can you see that? Whenever my hand is there, I can't see it. There we go. That's all it is. So when I plug in 5, what is it going to be? 2 plus 1. What are we going to plug in? 5. 10 plus 1, 11. 11. Okay. Thumbs up, sideways down. You got that problem? Okay. Because it's just like saying, hey, you plug in x, what do you get for y? Plug in x, what do you get for y? That's all domain and range are talking about. Okay. Domain and range as far as values go. All right. All right. Any other random questions? That's going to be the end of part 1. This will probably only let you do maybe 6 problems in the homework. That's about half of the homework. So you can go in on that or not. Monday, we will be looking at some of those initial problems, and we'll continue our second half. Thanks for watching.